So today what we're going to talk about is just the code, like you said, as a language. So we're not going to talk about algorithms or too much problem solving even yet. We're just going to look at JavaScript as a language and how do you understand it and how importantly does the computer understand it. We'll see that in just a moment. So you're going to think about how does a computer read your code to create a series of instructions, and how does a developer read your code to understand what you wanted the computer to do. And then we'll practice tracing variables. But if you don't know what tracing means yet, we'll get to that in a moment. So first we're up here. Let's just discuss this idea of source code, developers, and a computer. So if I scroll down a bit, there's this diagram. And we're going to try to keep this diagram in mind whenever we write or read code. So this diagram is something that we're going to want to keep in mind from now until forever. And what we're going to see is also a variation of this. What we're also going to see is the big difference between JavaScript and HTML and CSS. Often online you read about them and they're just kind of lumped together as one similar thing. But actually JavaScript is like from a different planet. And we're going to see why that is today. So if we think of our source code, that's just a file of text that you wrote in JavaScript. And so that's really where this connects to languages. When you write an email in whatever language you're writing it, you just write a text document. But then it gets interesting because normally when you write an email, you're writing to another human and only one other person needs to understand your email. And so you can just write it, you know how they think, you know that they'll understand you. But with JavaScript, what we see is you're going to have to write one document that makes sense to people, but also makes sense to a computer. So it's like you're writing an email in two languages at once. That same email needs to be understood by a person here on the left side. They need to know, what did you want this program to do? So we'll learn about commenting and variable names and other tricks like that over time that help you write code that a person can read. But at the same time, that code that you write needs to be instructions for a computer on how it controls data. So the user clicks a button. What happens after the user clicks the button? We need to go get this thing from memory. We need to send it over there. We need to do this, do that, do that. So your code needs to do two things. It's telling the instructions for the computer what to do when something happens. But it's also just like an email. It's a text document that a person needs to read. So that's something we'll be visiting today, is focusing on this link. So today we're really going to think about how does a computer read your code? Because if you don't start with that in your first weeks of programming, it'll be really confusing. And we can even tie this back into UX and UI design. The first thing you do before you build a design is you understand your user. How does your user think? What do they need? What are their skills? What are their limitations? So we're going to do that, but we're going to think of the computer as the user for your code. So we're going to spend today really learning, how does the computer interpret my code? What does it do? How does it read my code? Because until you understand your audience, you can't write for them. And if we look at this as a whole triangle, we see that a developer will write their intentions into the code at the top. We're going to pass that code into a computer, which will do a bunch of stuff. And then the computer will be able to console log. It'll print statements that tell us what's happening inside of the computer. So from here to here, you have the feedback loop, sort of like you had in UX UI design, where you make a website, the user uses it, and they tell you what happened. How was it? So that's a sort of analogy for what we'll also be thinking of today. You have source code, which is instructions for a computer. The computer uses your code, and the computer will print some output that tells you what it is doing. So we just looked at that. So that's great. Programming is writing code, and that code is a text that a computer and a person need to read. But where do we actually write that code, and how do you run that code?
So I think in previous classes, you've been using VS Code to write HTML or any other tool. Visual Studio Code, most of the people have been using it. So for JavaScript, it's a bit different. I think if we compare it to HTML, you write it in Visual Studio Code and you run it in your browser. For JavaScript, there are more options. You can write it wherever you want. It can be in Notepad, it can be in Visual Studio Code. but you can actually even just write it in your browser temporarily. And then you can run it in several places as well. You can run it in your browser, but you can also just run it on your computer from a command line or something else. But what's really important is that you keep these differences in mind, because when you see a tutorial online or you will see some material, some people write JavaScript in their console. I think you know this from HTML. So I think you know this inspect element from the previous classes, right? So there's a tab here, console, and it's used to display messages to the user, but you can actually just type JavaScript here. So if I write console log hello, it will print the next line, hello. I just wrote JavaScript and it executed at the same time. Keep in mind, there's two things going on here. I'm writing it and then it's being executed. When you are later in your career or later in this course, you will be writing several lines and then you will go to your browser or to your command line and executing them all at once. Whereas here, whatever I type is executed immediately. So if I write console log 1 + 1, it immediately executes 1 + 1 and then it prints the result to the console. Whereas later when you're writing, you will write a whole program, maybe a program to calculate how many days there are in a year, and you will write 5 lines or 6 lines, and then you go to your browser and you click on a button or something, and it will run these 5 lines. Later, Evan will teach us how to use study lenses, and study lenses is a tool created by Evan to both write and run JavaScript. The tool runs in the browser, so it's a bit confusing because we are not actually running JavaScript just in the browser like I'm running it here in the console, but Study Lenses is running the JavaScript for us. The reason why we're using this tool and not using this or whatever is the tool will allow us to learn JavaScript at an easier way. It will tell us what every line is doing, and it will help us to understand the lines better one by one. Because here the browser is not helping us. I can write JavaScript, but it's not telling me what's going on. Like, it's expecting me to know JavaScript. And so the tool we will be using will be helping us guide what's going on in each line. So you can copy paste a program in there and it will tell you step by step what is happening. So hopefully it will be helpful. In the beginning, it will be a little bit confusing because there's a lot going on. The JavaScript is being written, it's being executed, and the tool is helping you, telling you what's going on when it's being executed. But just keep in mind, you can write JavaScript anywhere, Notepad, Visual Studio Code, in your browser, in your command line, and you can run it from several different places, from your browser, your command line, etc.
I'm going to just talk about what we see here. And this is that world of a difference between JavaScript and HTML and CSS. When you write HTML and CSS, you write your code, you put it in the browser, magic happens, and you see a website. So sort of those steps between putting your code into the browser and seeing the website don't matter. You know the rules of CSS. You know that if you use a class, then it connects this item to that, but you don't know the steps that are happening along the way. You can just learn the rules and say that's why this became that. With JavaScript, it's completely the opposite. There's something that goes into your program, some data, then there's a lot of important steps. I could say that again and louder. There are a lot of important steps, and then there's a program output. And so this is that idea of learning how the computer interprets your code is focusing on a lot of important steps. So we're not, with HTML and CSS, for example, you can pretty quickly make an interesting looking site because you don't need to learn too much. You just learn some rules about how to change colors and sizes and shapes, which I know is complicated. CSS isn't simple. But ultimately, once you learn the rules, you can kind of start to make a web page without understanding everything very well. But with JavaScript, because this is what matters most, at the beginning at least, programs that don't seem to do much anything of interest, so they don't output anything interesting, are already very good for learning because we want to focus on the steps. So what we'll be learning today is how to study programs with very simple steps. And if you were to go home and tell your friends, I wrote a program that logs my name, no one will be impressed because what we're not thinking about right now is what goes out of our program. Right now, we're thinking about what happens inside of our program. So for the next couple of weeks, you'll be doing maybe something that feels a little simple. You might want to make something bigger faster, But what I challenge you to do is never write a program where you can't think of the steps, at least for the first week or two. Of course, at some point you do need to just like make stuff work. And that's one of the skills of being a developer, is just hacking something together that gets the job done. But at least at this phase in your learning, I want you to try to think about writing and reading programs that you get all of the steps. Or if you do want to study another tutorial online, don't just watch the video, actually pause the video, take the code that they're writing, and think about every step. Since most tutorials, they'll explain it, but they won't necessarily do the steps in the same way that we're going to show you. So that's the way that I'd like you to think about it. And if you go back to our diagram, what does this mean? This also means you're not just going to think about the source code and then what the user sees. You're going to think about the source code. How does the computer follow it as tiny steps? And then what is being outputted? Takeaway, simpler programs where you can focus on what happens between the input and the output. HTML and CSS, you didn't care about what happened in between. Now that's what we care about. So each of these little examples will show us something. So here we have comments. Bigger, okay, thank you. And the comments don't actually do anything. If we think again about this diagram, I should keep going bigger and smaller. So the comments that we're about to see, they're things that you write in a program that the computer ignores. So this whole part that goes from the source code to the computer, that doesn't happen with a comment. A comment is just there for the developer to read and understand what's happening. So in this example, if I open the console and I run this program with the run button, don't worry, we'll go over all these buttons. I know there's a lot. If I click the run button, nothing happens. And that's because the computer ignores these lines. These are just written for developers. So comments are where we're going to write instructions or explanations of what's happening in the code. As you go on, comments are maybe how you take notes on a program. You can leave a little note for yourself, like this line is doing this. And when you start collaborating, you can use comments to explain why you wrote your code a certain way so that your group mates can understand the code without having to read every line of code. They can read your comment and understand it. What we just heard is that comments are also for yourself, which is a really good point, because by the time you wrote your code, a couple minutes later, you might have forgotten what you were thinking, or at the end of the night, you can leave a little note for yourself for the morning. So the strings now. Strings is a data type. So the whole point of HTML and CSS is you make something that looks pretty on a screen, roughly. I'm oversimplifying. Front-end developers may not like that much. But HTML and CSS, at this point, at least what you've seen is you're thinking about what someone sees. Where with JavaScript, we're thinking about data. So things like a username, things like a password, things like my location. You can enter my address. So that's all data. And JavaScript programs, those very important steps in the middle, it's what are we doing with that data? Maybe we check the password. We compare it to the username. If they're the same, if they're right, we can log them in. So it's those steps that we're thinking about, but those steps need to store some sort of data. So string is one type of data in JavaScript, and it's just anything between quote marks. This is the data type that we'll be working with today. So it's just a way to have some words that are stored inside the program. So now this might be confusing next to a comment. You're saying, but like this is a word and this is a word. But you have to be very careful paying attention to the syntax. Here we have 2 slashes, which is telling the computer, ignore this. But here we have 2 quotes, which is telling the computer, this is important, save it in your memory. This is written with single quotes, but you can also write it with double quotes on a keyboard. I will figure this out. Yeah. There.
So if you start a string with a single quote, you have to end it with a single quote. They have to match at the start and the end. And the last example is actually a good example. If you start with a single quote, you can use double quotes in your string and it will work fine. But if you want to use double quotes and you started with a single quote, or if you want to use single quotes and you started with a single quote like now, what actually happens is the first single quote it reaches, it starts. So before cows, the string starts. But then before moo, computer thinks the string is done because it stops at the first single quote it sees.
The examples you're going to see here have single quotes, but like you said, it's not because it's right. It's just because that's the one we're using. So you could go through and replace all of the single quotes in these exercises with double quotes, and it would still work. So console log, this is when we're going to start to see something. So now we have a program with a comment up here, a multi-line comment explaining what the code does. So that's something we wrote for you to read. Above each console log, there's a single line comment giving a little more explanation about that line of code. But now we actually have something that does something. Any guesses? What we'll see in the console if I click the run button? Why do you think nothing? Yeah. So because there's nothing between these two quotes, you think we'll see nothing? Let's see it. So it's sort of nothing, but it also isn't nothing. So there's 4 logs, 1, 2, 3, 4. And in the first one here, there is a log, but there's nothing inside of it. So you can see there's an empty line, but there is a line. So every time you do console log, there will be a new line in the console with some information. That information might be nothing, but that's still something because we still decided to print a string. There was just nothing stored inside of that string. This is also one of those weird things that doesn't exist in HTML or CSS, is like this idea of empty data is still data. We're going to see this coming up later also with things like empty arrays and whatever for later. Yeah, so here we have a log. And then the next ones, it's just pretty obvious, at least in the first 2. It's what you see here is what you see on the left. The little slightly trickier one is down bottom. You can actually print more than one thing using a comma. But that's not super important. You'll see it pop up here and there. This is more just here to say it's possible. It's not so important for what we're going to learn today, but it's possible. So in JavaScript and many programming languages, there's a special character, which is a backslash. It's called a backslash. It goes from the upper left to your lower right. And that sort of says to JavaScript, wait, the next thing that you're going to see isn't actually an N. It's a confusing thing. You'll have to study this. It'll take some time to sink in. But what I can do here is I can say, wait, JavaScript, don't print the letter N. This is actually a new line. Now, if I run this program again, we see that there's a new line. So we have 2 lines of text here. But if you look at the size of this box, it's still just 1 log. We don't see 2 numbers. I can make this as long as I want. Now there'll be 3 new lines. But still it's 1 log. So that string contains multiple lines inside of it, but it's still only 1 string. So yeah, a string doesn't need to be only 1 line. So then we'll look at one way that you can actually do something with strings. So let's take a look moment quickly at this first too. So before we look at what we can do with strings, let's review how console logs fit in this diagram. So we had the code that I wrote, which had console log in it. I clicked run, and there were 4 logs. It was like an empty line, a new string, moo, hack your futures, like 4 things. So those are the 4 steps that the computer followed. And then there was output, logs. So for every one of those steps, the computer printed something in the console. So that's this communication that we have going, where maybe communication depends on if you think you're talking to a computer. So where I told the computer what I wanted it to do, I wanted it to print 4 things. And then in the console, I could see what the computer actually did because it printed those 4 things. So that's closing this loop. So now we'll look at string concatenation. which is just where you can combine two strings into one string. So so here the answer is already written in a comment. But this is 4 different ways to just make the word hello print. See, the output is exactly the same, but the steps in the middle are different. So we can do this with a little trace button. Don't worry too much. So we highlight this line and trace. No, actually, that's unhelpful at the moment. So we'll just run it. So what we see is, remember this idea that what's important with JavaScript isn't the input and the output, it's all of the steps in the middle. So what we see with these 4 lines is exactly the same output, hello, 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 but we got there very different ways. Well, depends on what you think very means, but we did different things to get to the same output. On line 9 here, we combined hello with an exclamation point. So we took 2 pieces of data and we made 1 new piece of data. On line 10, we did the same basic thing. We took 2 pieces of data to make a new piece of data, but they were different. Our left data said HEL and our right data said LO exclamation point. When we combine them, we get the same output, but we follow different steps to get there. So this is again that idea. What's important in JavaScript isn't necessarily what comes out, it's how you get there. So this gets even more interesting on line 12, where we see we actually added together 4 different strings. We had 4 pieces of data that we combined into one to print hello. The output is exactly the same, but we followed different steps to get there. So that's also this idea of learning JavaScript as a language, is when you go to learn Dutch or French, they don't say, write me a paragraph. They say, we're going to spend the first 3 weeks reading paragraphs. We're going to learn how to diagram sentences. We're going to review vocabulary. We're going to do some fill in the blank exercises. Or they'll say, like, take this paragraph and change it a little bit. So we're going to be learning JavaScript the same way. So that's why you're going to have a lot of examples and exercises. The example illustrates something about the language. You study that, and then you figure out how to apply it in your own exercises. So yeah, this is a stupid program. It doesn't do anything. It prints the same thing 4 times. But if you step back and say, my goal isn't to do something interesting, my goal is to understand the steps, then you can still learn a lot from it. Can someone see what's the difference between this log and this log? And this is just a little challenge about the syntax, in that you do need to pay very close attention. Things that look similar might not be. Yep, there's a comma instead of a plus. So if you remember from the previous example, you can print more than one thing. So here we're actually printing 2 things. The first thing is combining J, ja, and va. That's one thing, we're going to print it. Then we're going to combine sk and ripped to make a second thing that we're going to print. So this is another little example where they look very similar in the output, but how you got there is very different. And so if you don't understand or remember everything I'm saying, it's recorded. And the takeaway message is that it's these little steps in the middle that matter. And so you should pay attention to them. It's not a space. It's actually 2 different things. Let's make this here real quick. Space.
The second output. The second. It prints a space.
Yeah. Because you did 2, because of the comma. So I'm going to show the difference between an actual space and 2 things. So the reason that you saw that extra little space there is because there are 2 things. So these look identical, and this is where the console can sometimes be confusing. But in this example, I added a space between Java and script, or maybe it's easier without the concatenation. And we just see that I'm printing Java space script. And here I'm printing Java, comma script. So let's clear and run that again. They look identical, but they're actually different, and you can't really tell how. So the console isn't perfect. And this is where you need to learn to look at the code and become JavaScript. You need to learn to read the code the way JavaScript will read it. You can't simply trust the output in the console. You need to be able to look at these. And you'll get this a lot too when you start learning about the DOM and you start making interactive programs. There's a lot of ways to make the same thing appear on the screen that aren't actually the same behind the scenes. So it's a good, even this little mini example of what you see isn't necessarily the same as what happened is actually a good little lesson. Yep, so here, like you said, we're printing one string, one piece of data that has a space in it. And here we're printing two pieces of data, and it's actually the console that's adding a space between them. Okay, so now we're going to look at variables, and this is where things are going to get a little more complicated. Up till now, we just printed stuff directly, but we didn't actually save anything in our memory. So if we think about the idea that a JavaScript program is things that come in, many important steps, and things that go out, those important steps, we're going to start seeing them as well. So those important steps involve things like saving data for later. Let's say that you're on a website, you log in, you switch to a new page, you still want the web page to remember that you're logged in. So there needs to be some way to save data for later. It needs to remember when you're on the new page that on the last page you logged in. So the simplest way to save data is variables. A variable, you can think of it kind of like a box. You can put a value. If I had this bag here, for example, I can put the number 3 in it, and then I can go eat a cake. I can come back, and that 3 is still waiting for me. If I remove the 3 and I put in a 4, then now there's a 4 stored in that variable instead of a 3. So that's a good enough analogy to start understanding variables at this point. So if I run this, we see there are 3 logs. So how many things will we see printed on the side? Any guess? We'll see 3 things. And we see that each one is logging X. So what do you think we'll see logged every time? So the person I can hear the most clearly is saying that we'll see 3 different things. But why are we seeing 3 different things when I'm logging the same X every time? So what we're doing here, we're saying, let's declare a new variable. So like, let's build a new box. We'll name that box X, and we'll put hello inside of it. Declare, yep. And then on line 21, we're going to say, let's take whatever is in that box and let's print it. But then what's happening on line 24? We're taking out hello and we're putting in goodbye. So on the next line 27, when I try to log X, what's in my box right now? What am I doing on line 32? Yes. So we're keeping that value we had before, goodbye, and we're adding an exclamation. So now in our box, when we try to read it, it'll say goodbye instead of goodbye. And so this is that idea of instructions for a computer, not at all being what you see at the end. When I run this code, we're not going to see a new variable was declared. It was initialized. We're not going to see anywhere in our console that X was assigned a new value. We're not going to see anywhere in our console that we added an exclamation point. All we see is the logs. So you need to learn to read the code like a computer and step through it exactly the way a computer would so that you know what's going to happen ahead of time. So there's vocabulary, declare, initialize, read. We can look at those maybe better in small groups so you can actually ask your questions. So what we're going to look at quickly now because we now actually have some code that does something, we'll look at some of the features in study lenses that you don't have in Visual Studio Code or other places. So you see, all good. So a quick little introduction, we have these buttons, and instead of just running our code, there are other ways we can study code. So for example, if we click this variables button, it will highlight all the variables in our code and tell us how they're being used. So there's a little key up here. In yellow is when a variable is being declared. In red is every time we're reading it. Green is every time we're assigning something to it. So putting a new thing in the box. Declaration is creating a new box. Reading references is looking what's inside the box. Assignment is putting something new in the box. So we can scroll down. We can hover over X and it will show us every single time X is used in this program and how it's used. And so in this way, you can start to learn, how does a computer read my variables? How is it being used at each point in the program? So here we're building our box. We're creating a new box. Here we're looking at what's inside of our box, the read reference. Here we're putting something new inside of our box. What do you notice about line 32? So yeah, you're using this variable twice on one line. And as we'll see in a moment, you said I assign it and then I read it. Not actually. So the computer is actually first going to read the value and then assign a new value. So that's one of the things we're really going to focus on today, is how does this equal sign work? What does it mean? And what it actually does is it will look at what's on the right-hand side. It will do everything, and then it will put something into the box. So first, we're going to read the value that's stored in our box. We'll add an exclamation point to it, and then we'll put it back in the box. So this is one lens that can help you understand how variables are used in a program. Another one that you might find helpful is this button, Parsonize, and it creates a click and drag exercise. So which is the first line of our program? You can drag it over. Which one is next? Does it matter which one I use? No, they're all the same. Which line is next? Goodbye, you said?
Yes.
Okay. And then what are we doing after putting a goodbye in there? Next. And then the last thing. And then we can get feedback. We have too few code fragments. So we missed a line. There's still a line on the left that we need to use. So these exercises are really good to make sure you actually understand what the code does, because it's very easy to look at the code and say, yep, I kind of get it. It sort of does this. Those lines do that. Great, move on. But this will really test your knowledge. Do you actually understand the program as well as you think you do? And this is another one of those exercises where you're thinking, I'm not writing a program, I'm studying it. From this idea that a language, you don't learn a language first by just being given a blank page and writing an essay. You're going to have these different exercises that help you understand what's happening first. Flowchart is interesting. We can just look at blanks and then the rest you can explore later. So blanks is going to create a fill in the blanks exercise. So there's different parts to the JavaScript syntax. There's identifiers, which is things like X, console, log. They're words that you can sort of decide what they're called, but there's also keywords. You'll see those often in a different color, like let, while, if. And this is, I know this is a lot right now, but these exercises are here. There's more material on this. But this is that idea too of let's learn the syntax very carefully. And let's not just say this line kind of does that. No, let's say this is a keyword. This is an identifier. This is an operator. And this is a primitive value. So to really be able to go through and break down the syntax of the code. And what we can do is we click and drag this, and it will replace something, and we have to remember what went there. So what do I write here? For a hint, I can see what's been removed, but we're better than that right now. So what goes in this blank? And what goes in this blank? And we can see that it's good because all the red went away. If you want a little help, you can also show this and you can compare back and forth. Right now it's fine, but when your program is larger, you might appreciate a little more help. So what we can also do, we can say not keywords and identifiers. Let's look at all of our data. So the primitive types. Let's only remove those from our program. So what was written at the top? Do I need to put single, double, quotes, anything around it? Use strict. What was the first data that we used here? Hello? But notice the line is still red and it's highlighting what's wrong. So we can quickly check our mistakes. Yeah. So this is that single double quotes. The program, it replaced the single with the double quotes. So I just have to remember that and use double quotes instead. Huh? There, I don't need a shift. So now, there, I remembered it exactly. So this might feel slower. You want to see cooler things. You want to write programs. But keep in mind, if you are trying to write a cooler program, you still have to remember these details. And so just think of it like flashcards. Think of it like just memorization. It's sometimes in programming, you need to memorize things. Sometimes you don't. This sort of low-level syntax you should memorize, because when you're focused on solving a problem, you don't want to get distracted by trying to remember, do I put a curly brace or not? You want to be able to focus on the problem you're solving by having these details just memorized. So what was the next data? Does anyone remember? Cool. And then the last one. Eight, yeah. So there. And what you're also seeing here is there's so much you can learn from even a simple program. There's so many different ways you can study one little piece of code. So you don't need to study 15 programs. You can study 3 or 4 programs in a day, but really study them deeply. And this will help in the long run too, because a lot of problem solving and programming is just remembering something that you've seen before and using it again. And you don't remember something just by skimming it over and moving on. You remember something by studying it more deeply. So by going through these, by studying these examples, by really understanding how they're written, then you're building up your memory of ways to solve problems. So later on, you don't need to figure it out. You can just remember a solution, move it in and adapt it. So the last thing we're going to look at is this trace button. And this trace button and trace tables. So the idea of tracing is being the computer. Right now, what we saw is if I click the run button, the computer does the instructions. But can you test yourself and do exactly what the computer will do without the computer doing it? So we're going to close our console. We can open a trace table and we can try to become the computer. What is the first line of code that happens? Just the number of the lines. So looking over here, which is the first number of line of code? 18, there. And what variable are we working with?
Yes.
What are we doing to it? Yeah. And here we can use this lens. Remember, we can hover over and see what's happening. So this lens can help us solve this problem. What are we doing to that variable on line 18? So we're going to declare it. And actually, we're also initializing it because there's an assignment on the same line. And what value are we putting inside of it? I won't worry about the quotes. This is just notes for ourselves. So what's the next line of code that uses X? 21. Again, it's not interesting. There's only one variable, so it's X. This time we're reading the value. And what's stored inside of our box? What's our next line? Variable X, what are we doing? It says assignment because we have the equal sign, but not the let. So we're not building a new box. We're just putting something new inside of it. And what are we putting inside? What's our next line? Reading. And now this is where you can't look at the code. If we looked at the code, we might see line 18 and think that we're going to print hello. So what we're actually writing here is the steps between the input and the output. So where do we look to see what's currently stored in this variable? We look at the lines in our trace table. So we're not going to necessarily look at this code. We're going to look at the trace of our program and see what was the last thing that we assigned to our variable. So you just look from the bottom to the top, find the first assignment, And that's the value that you'll be reading. Which is our next line? 30 what? 32. And we're again with X. What are we doing first? I'm hearing two things. I'm hearing some people say we read first. Some people say we assign first. So why does it make sense that we need to read before we can assign? So if you want to get technical, yeah, the precedence is higher. But if you just want to think bigger picture, exactly. If I'm assigning a new value before I read it, I've gotten rid of the data that I needed. Or from the other perspective, how do I know what I'm supposed to add an exclamation point to if I haven't read what's in the box? So first I need to check what's in there before I can use it. So on line 32, we're going to read and what's stored inside of it. Goodbye. Yep. Now, what's the next line of code? That exactly. So it's actually again line 32. And so this is where if you look at the code, you might just tell yourself in English or whatever language you're thinking in, you would say, oh, I'm just adding an exclamation point to what's inside of X. But that's not how the computer thinks. And that's what we're trying to learn here is how the computer thinks. What are those tiny steps that the computer follows? And how can I learn to think like the computer so I can write instructions that the computer can follow? That will also help you fix your bugs later, but later. So go bigger. Yep, so I've actually done two things on one line. First, I read, then I assigned. Voila. And then what's the last thing that we do? Declare? So why do you think it's declare? Did someone say declare? Yeah. So what made you think it was declaring? Okay, never mind. So yeah, I also heard read. On this line here, we're just going to read the value stored in X to print it. And the value we're going to read is goodbye, because that was the last one that was assigned with it. Yeah, man. Just 8. Got it. There. So there's a trace table, and this is the exercise we'll be focusing on today. It gets boring after a while. You don't want to only do this, but it's helpful to learn this while you still have us around so that over the week you can use it when you need to. So the last thing before we do split into groups is to show that you can actually check your work. So we don't expect you to do these perfectly.
I think it's 3 lenses, or I have an old version. Oh.
I know that. It's just, I used clickable or something from jQuery, and it's not so great. All right, so what we can finally see before we go to groups is this button called trace will actually tell you the answer. So we can trace the program. Actually, you can sort of choose what you want to trace. So for right now, I'll turn off operators. Yeah, that's cool. Trace. And how do I make that part smaller? So it's on one line. Cool. Is that too small? Yeah. What did I just do? Escape. And same problem.
I double click next.
There. So now we can actually check our work and see if we were right. So in this trace, it tells us the first thing that happens is on line 18, we're going to declare X using let. Do we have that in our trace table? What's the next thing that we do? Step 2. To which value? Did we get that right or did we get that wrong? Yes, but that's fine. That's why just a display thing. But we did the same thing. We have the comma there saying declare and initialize. And then we can go through. We don't necessarily need to do that right now, but you can go through in your groups, and this is how you can check your work.